This is AGNR 131, Soil Science. This is Lab 5, which is about soil moisture. And this is Part 2, which is field capacity of soils. How much water can a soil hold at field capacity? And you should probably have already read your lab handout. You'll know what those terms mean. We'll talk about them again in lecture, and you'll have them down pat without a doubt. So what we're going to do here is we're actually going to take our soils again. We know they're different types of soils with different characteristics, and we're going to weigh them out this time. Here's our familiar funnels and filter paper. We're going to weigh them out. We're going to weigh the same amount of soil out for each one of them, 20 grams of soil, and then we're going to add water very carefully until it just drips out the bottom. That's going to be our saturation point. At that point, we're going to stop. We're going to wait, make sure that no more water drips out, and then we're going to actually do that again, right? And then when that's all done and the dripping stops, in other words, when the soils, each one of the soils has held as much water as possible, no more water is dripping out, we're going to weigh the soil with the filter paper. The filter paper is to make sure that we don't lose any soil, and we're going to put it on the balance. We know we started with 20. We know that the filter paper weighs 3.1 grams wet when it's saturated but no longer dripping. So we're going to be able to take that number, that 3.1 grams, off of our total wet soil measurement. And we're going to see, based on a weight measurement, which we can convert to a volume measurement, how much each one of our different soils, how much water it can actually hold at field capacity. That's against the force of gravity. How much water can each of our soils hold with their different textures or different characteristics against the force of gravity. So I'll get this all set up and then we'll come back. So here we go. We have 20 grams of soil in each one of these three funnels. So what I'm going to do now is I'm just going to go ahead and add water carefully to this and to each one of the soils until it just starts dripping. As soon as it starts dripping, I'm going to stop, and I'm going to let it stop dripping, wait for a while for the water to saturate through that soil completely, move through the soil, and then I'm going to add some more water and have it keep dripping, and then we're going to do the weighing at the end of that. So here I go. I'm just going to carefully add water. I'm not going to squirt too hard. I'm just going to try to cover the whole soil surface of it, and I can do that, and then I can go to the next one, and just gently add a little bit of water. Don't give it too much pressure. Same with this last one over here. Get the whole soil surface all wet. And then I'll do a little bit more on this first one, and we'll just continue to do this until water starts to drip out the bottom. So we can see that the middle one here has already started to drip, so we don't need to do anything more with that. We're just going to let it drip a little bit, and I'm going to add a little bit more to these guys because they haven't quite started yet. We're just going to keep doing that one, but this guy in the middle here, he's pretty well done, or it's pretty well done. Well, we've got them all dripping now, except for the middle one's now stopped. So we're going to wait on that one and continue to wait for probably at least 10-15 minutes to make sure it doesn't drip anymore, and let that soil completely saturate, just in case there's some dry spots in there. The other two are dripping. We're going to let them drip. We tried to be careful and only get just enough water in there to get it started. So we'll wait a little bit now, let them stop dripping. Then we're gonna video again once they've stopped dripping, and then we're going to add some more water until they start dripping again, then wait for them to stop, give them enough time to completely stop, and then we're going to weigh the different samples. All right, so we've waited for our 10 or 15 minutes. We lost count after 10, but there's been no more dripping. So now what we're ready to do is we're ready to add a little bit more water very carefully to start that dripping again. We want to make sure that there were no dry spots in any of these soils, any of the funnels. So I'm just going to carefully do the same thing, just spread water all over the surface of this soil, just of each one of the samples, just a little bit, and make sure it covers the whole area until it starts dripping again. We can see this one's already started dripping. I'll wait and see what happens with the other ones. One step, the middle one's dripping as well, and so is the last one. So now what we're going to do is we're done. We're going to wait for these to continue or finish dripping, totally finish dripping. We'll wait for 3 minutes after the last drip or so, and then we'll take them out. We'll come back and take them out and weigh them and see if we have any difference. We don't know, maybe we won't, but we should have some difference in the amount of water that each one of these soils has held. Okay, so we're ready for our final analysis here and to see if there's any difference between these three different soils with very different properties, to see if they're able to actually hold different amounts of water at field capacity. Always have to itch my nose when I'm on camera here. So I'm going to take the first one, A, and see if I can carefully take it out of the funnel. and I'm just going to lay this whole thing with the filter paper on my balance here. All right, so my handy assistant's going to record 32.6 on this one. So soil A there is going to be 32.6. So let's check the next one. I got to wipe it off here just a little bit. Whatever water might have sat there. So I'm back to tear it out at 0. I'll take the second one. Carefully take it out. Well, this is definitely a little different. This is only 28.1. 28.1 for soil B. That was our sandiest soil. And tear it out again. And our final soil, the one that was I think that had the most clay in it. Carefully put it down there. And it reads 31.7. So different weights, but the most dramatic one was with the sandiest soil. So that's actually not really surprising. I would have kind of thought that might be the one that would hold the least amount of water at the at field capacity. So we can analyze that. We can have a look at those, make a comparison between those three soils, and we can actually use that to extrapolate to the larger real world situation or the field situation if we wanted to.